We're going to be looking at two different examples that'll help you with your key features of graphs paper. It does say Monday at the top, but it is going to be Tuesday because they ended up giving us a snow day on Monday. So this is the first graph that I'm going to be filling out as an example. So if you want to take a picture of this when we're done, take like a screenshot of it, or write it down as we're going, this would be excellent for you as your notes. We're going to go through each different part and I'm going to explain it as we go. First thing we need to fill in is the domain and range. Domain, I'm going to write some notes on it as we're going. So this is all the x's. So we're going to figure out how far left we go and how far right we go. If we've got arrows on both ends of the graphs, we're going to figure out that the graph is going to continue forever and ever and ever. So this graph is never going to end. So if we write with interval notation, I can go from negative infinity to infinity. I can keep going forever left, forever right. If you prefer the inequality notation, I have x is greater than negative infinity and x is less than infinity. You do not have to put both notations. Pick one, stick with it. We're going to do the same thing with range. Domain is the x's, range is the y's. We figure out what is our smallest number that the y's can be, and then what is the largest number. We have arrows going down and arrows going up. So just like the domain, we can have any possible numbers. So we're going to have the same things we had for our domain. We could have any possible number in there. We've got to figure out next x-intercepts. X-intercepts are where they cross the x-axis. So I have 3 points where I'm touching the x-axis. I'm going to start them left to right. It doesn't matter which order you put them in. Just make sure you get them all. So my first point is -2, 0. My next one is 2, 0. And then I have 3, 0. The 3 points where I cross the x-axis. Now I'm going to find my y-intercept. This is going to be where I cross the y-axis. So I'm going to find the coordinates of the point where I cross the y-axis. Don't go left or right, so my x coordinate is x, and I'm going down 3. That gives me my x coordinate. Next, we're going to go into minimum and maximum. I know they're separated because I cut this up. We're going to do these at the same time. There's 2 different kinds of maximums that you could have. The first one, you can have an absolute or a global. Those 2 words mean the same thing. You may see one, you may see the other. I'm going to write both. You can choose either one because I'm going to just put one when we do the next example. Absolute or global means there's absolutely nothing higher than it. So the absolute highest number that we get on our graph is going to be infinity. Because if we continued our graph up, we're going to continue up forever. There's nothing higher we're going to get. Our other type is a local or a relative maximum. So this one is going to be like the top of a peak. So this is the point where you're on the top of a roller coaster and you get that weightless feeling. So we're going to see, where do we have the top of a peak? We have that at 1 point, 2.5, 0.25. A maximum is also, we're going to look at it in a little bit, where we're going to change from increasing to decreasing. We're going to jump down to the minimum. The absolute minimum, the very lowest number that I can get on this graph is negative infinity. The lowest output is negative infinity. My local minimum, if I had my local maximum as the top of a peak, local minimum is the bottom of a valley. A local minimum is going to be the bottom of a valley. So it's going to be down here at the bottom at negative 1/2, negative 3.25. That's going to be where you hit all those G's at the bottom of a roller coaster. It's the bottom, that is our minimum. Now, I want to figure out, where am I increasing? Increasing is a positive slope. So decreasing would be a negative slope. So to figure out positive versus negative slope, positive is when we're going uphill. Your slope is going to look something like this. Negative slope is going to be the other way around. So I'm going to mark up on this graph everywhere that has a positive slope. So like if you're on that roller coaster, you're going uphill. Everywhere that is decreasing is everywhere that I am going downhill. So we have 3 different areas. We need to separate those into the increasing and decreasing. So for increasing, I am increasing between negative 0.5 and 2.5. We're going to put parentheses at the end because at the end we are changing from increasing to decreasing. We are not increasing or decreasing. It's a transition point. We can do the interval notation or we can do the inequality notation. Here we're transitioning again, so we're not increasing or decreasing at either point. So we've got our one region where we're increasing. Now we're going to represent this region of decreasing. So I'm going from negative infinity up to negative 0.5. And then I need to do my other region. I have from 2.5 going through to infinity. My goal with increasing and decreasing is I'm going to use the whole domain. On increasing, decreasing, and when we get to positive, negative, we're going to use all of the domain up. So I've covered up negative infinity to negative 1/2. I pick up at negative 1/2 to negative 2.5, and then positive 2.5, and then positive 2.5 to infinity. I cover every part of the domain in increasing or decreasing. I'm going to write it. I've got the interval notation. I'm going to write it as inequalities. So I have all numbers less than negative 0.5, numbers greater than 2.5. That gives me my increasing, decreasing. Now I want to figure out, where am I positive, where am I negative? Positive is going to be above the x-axis. And if positive is above, negative is the opposite. Negative is below. So everywhere that is positive, I'm going to color in yellow. So this whole section here is going to end up being positive, because all of my outputs are going to be positive. Let's see, what's negative should be what's left. This whole section of graph in the middle is under the x-axis. And then once I get past 2.5, everything there is under the x-axis. So we're going to try to represent these regions. I have two positive regions. So I have x's that are, let's do interval notation first. I got negative infinity to negative 2 first. That represents my first region. Then I have from 2 to 3. Those are my two yellow regions above the x-axis. So that gives me x is less than negative 2, and any x's that are between 2 and 3 give me numbers that are above the x-axis. Now I want to do the same thing for below. Below I have negative 2 to 2 and 3 to infinity. So I can write those as any x's between negative 2 and 2 and any x's greater than 3. All that we're sitting at left is our end behavior. So we have to figure out what happens if the graph continues forever, or what's going on at the ends, because we've got arrows. So we want to figure out what happens at the right end of the graph and the left end of the graph. On the right end of our graph, it's going to continue to infinity. Our x's are going to infinity, and what are our y's going to? Y's are going down, so they're going to negative infinity. On the left side of our graph, x's are going to continue left forever still, so they're going to negative infinity. The y's are going up this time, so they're going to positive infinity. So if you want to take a second, take a screenshot before I move on to the other graph, because this one's just a little bit different. Alright, we're going to go a little bit faster with this one. So we got domain and range again. Domain is going to be all of our x's. Here our graph is a little different. We do not have arrows on both ends. Here we have a hard stop at negative 3 and a stop at 4 on the right. At negative 3, we have a closed dot. That means that point is included on our graph. We can have negative 3. We have an open dot at 4. It means we get really, really close to 4, but we do never actually get there. So we can have like 3.999, but we do never get to 4. So we're going to take a second and write out the domain with inequality notation. Anytime you have a bracket, it's going to be an equal to. So I go from negative 3 to 4. And now we're going to do the same thing with range. I start at the bottom of my graph. My hard stop is at negative 4, and it's got a closed dot because that point is included on my graph. Now I see where is the absolute highest point on my graph. The highest point on my graph is 2. I don't have an open dot there. That is just on my graph, so it is it's a bracket. Both of those are a bracket, so I go from negative 4 to 2. I have both of those points on my graph. My x-intercepts were where I crossed the x-axis. I have 2 this time. I have 1.50 and 3.40. We have one y-intercept where we cross the y-axis, 0, negative 2.26. I'm not going to write the whole thing out. Now we have to figure out our maximum situation. We have to figure out, do we have an absolute and do we have a local? First up, what is the absolute maximum? What is the full-on highest point? Our previous one, we kept going to infinity, so we couldn't define a point. Here, we have a point that is our absolute maximum point. 2, 2 is our maximum point. And well, 2, 2 is also the local maximum. It is the top of a peak. We do not have any other tops of peaks on here. This is the only maximum that we have. We're going to see about the minimum. The absolute minimum, the very lowest point on our graph, no point lower than this, is -3, -4. We do not go any lower than that. There are no valleys that we've got on here. We'll come back to this. We'll leave it empty for a second because we're going to do the increasing, decreasing. That way I can show you there's nowhere we're going from decreasing to increasing because we have no local maximums. So just like we did with the previous one, I want to highlight everywhere that I am increasing first. So everywhere I have a positive slope. So everywhere I'm going uphill, and then everywhere I'm going downhill for decreasing. And then we're going to represent those regions. I only have one for each this time. It's not as complicated as the last one. So increasing starts at -3, and it stops being increasing at 2. So I'm going to write that -3, 2 as any x's between -3 and 2. My decreasing is from 2 to 4, or any x's between 2 and 4. So I had one spot I went from increasing to decreasing. That gave me a maximum. I have nowhere that I went from decreasing to increasing, so I have no minimum this time. We're going to figure out where am I positive and where am I negative. Positive is where am I above the axis. Negative is where am I below the axis. So for positive, we only have one region. So I become positive at, what point is that? 1.50. So I become positive at 1.5, and I stop being positive at 3.4. So any x's between 1.5 and 3.4 give me positive values. Negative is going to be everything else, everything that I have here in pink. So anything starting at -3 all the way up to 1.5, and everything from 3.4 to 4 give me negative values. Or if we do it in the other notation, -3, 1.5, and everything between 3.4 and 4. Our last thing we've got is our end behavior. Now we're going to talk about what happens at the right end and left end. So on the right end of our graph, we are going to end at a number. So x is going to 4. We're getting really close to 4. And the closer we get to 4, y is going to -2. We're going to a stopping point this time. When we go left, x is going to a point of -3, and y is going to a point of -4. So take a minute if you want to take a screen capture of this. These are going to help you while you fill out that front of that paper, because this is a good summary of everything from the couple days that we were in class together.